Welcome back. We are in the middle of this example where we have these two equations. This is a system of equations, and we are trying to solve by graphing. So first I graphed the circle, and then I wrote this line in y equals mx plus b form. I have a y-intercept of -1 and a slope of 1. And so we can see that there are 2 points of intersection. There's a point right here and there is a point right here. And it's kind of hard to see because it's a circle, but we can verify what we found algebraically up here, that we have one point of intersection at 4, 3, and we have another point of intersection down here at -3, -4. Solving by graphing is kind of cool in this section because we can have all different types of solutions. Let's think about if we had a hyperbola and a parabola. We could potentially have 2 points of intersection. Or if we had a circle and a parabola like this, we could potentially have no solutions or no points of intersection. We could have an ellipse and a circle, and we could have 4 points of intersection. So there's going to be a bunch of different types of solutions that we could find. Let's take a look at this example. We're asked to solve the system. And if we think about what types of conic sections these are, well, we have a 3x squared and a -2y squared. Because they're opposite sides, I know that this is a hyperbola. This equation, because we have an x squared and a y squared, they have the same sign, but they're different numbers. I know this is going to be an ellipse. Well, if I think about writing this ellipse in standard form, I would have to divide by 77 for each term. Well, that would give me fractions, and that's going to be kind of tricky to graph. So let's solve the system algebraically. Remember, solving algebraically, you can either use substitution or elimination. And since this is written in a pattern that makes it look like elimination is going to be easiest, that's the technique I'm going to use. To use elimination, my goal is to create either the x's or the y's to have that same leading coefficient so that we can easily subtract them and cancel them out. I'm going to multiply the top equation by 2. So we get 6x squared minus 4y squared equals 60. I'm going to multiply that bottom equation by -3. So we get -6x squared minus 15y squared equals -3 times 77 is -231. And now we can add these equations together, which will eliminate the x variable. So the 6 and the -6 cancel, -4 and -15, when we add those, we get -19y squared. If we add 60 and -231, we get -171. Next, we can divide by -19 on each side to get y squared equals 9. Well, if y squared equals 9, we can think about taking the square root on either side, and y equals positive or -3. Y equals positive or -3. So we found 2 values for y. I'm going to come over here and think about my solutions. Being sets of ordered pairs. We could have a y value of +3, or we could have a y value of -3. Now my goal is to solve for the corresponding x values. So I'm going to think about if y is 3, what is x? Well, we can go back to any of the equations that have both an x and a y. I'm going to choose this top equation. That top equation has 3x squared minus 2y squared, so 3 squared equals 30. Simplifying, 3 squared is 9 times 2 is -18. I can add 18 on both sides. Adding 18 on both sides, I would get 3x squared equals 48. And then we can divide by 3 on both sides, and x squared equals 16. Well, if x squared is 16, then x can either be positive or -4. So we just found out that when y is 3, x can be either positive or -4. We can go through that same process when y equals -3. 3x squared minus 2 times -3 squared equals 30. Well, -3 squared is 9. 9 times -2 is -18. And so we can see that we're at the exact same point in the process. So skipping ahead, we get x equals positive or -4 again. What this means is when y is -3, x can be either positive or -4. So in this case, we actually get 4 solutions. We get 4 coordinate pairs. And let's write all of those out. We get +4 paired with -3. We've got -4 paired with 3. We've got +4 paired with -3. And we've got -4 paired with -3. That's it for our lesson today.